Okay, we're looking at the formwork for a slab. Okay, I need you to turn to page 614. I want you to follow me and then edit or put notes on your handout. Hopefully you've got it printed. Okay, you can also follow it online if you want to. In the files section of Canvas will be the 3 chapters, so you can follow it online. Okay, we're going to do an example problem. It's on page 614, right-hand column. About 3/4 of the way down, it says slab form example. So I'm going to gather the data first, and then I'm going to show you how I do it. And I told you, I left those equations over there on purpose, okay, from last lecture. So we can go through our iterations in a fashion that hopefully makes sense. Okay, so we've got slab design example on page 614. The forms to support a slab 8 inches thick. Slab, T equals 8 inches. With the conventional density of concrete being 150 pounds a cubic foot. If you don't have it, put it down. We're going to use sheathing, 1-inch boards. Sheathing, 1-inch boards. So in this case, they gave me the thickness of the sheathing. I'm going to design the spacing of the joists. Okay? So the fatter the sheathing, the farther apart the joists can go. It's going to be construction grade Doug fir larch, Doug fir. So it's Doug fir construction grade. Writing that down. The ceiling height is 8 feet and the bays are 15 by 15. I'm just going to use that as data. They don't really use that a whole lot in this problem. Why you would use it, so you can size the spacings that conform to the format that you have. Okay, so if you got 15 by 15, that's 180 inches. Make it so that they divide out equal when you pick a spacing. Okay, the first thing they do then, let's see, since all forms will be used only once, only once. Hopefully that rings a bell. In that table we had, I told you that there was 2 separate areas of table 4.2 that you had to worry about. Moisture and using duration. Okay? Once, we said if we use it once, we can multiply our stresses. So that's what that's there for. Provide for short-term loading on page 4-2 or table 4.2 on page 4.5. That's that table I alluded to. So step 1, find the loading. So first thing we do is find W. So number 1, find W. And it's W1 in my world, okay? W1, you go back to chapter 5. You look on page 5.1 and you say, okay, do they say anything about carts? No. So live load is 50 pounds a square foot. If it was with carts, it would be 75. Dead load is the thickness of the concrete in feet divided by the density. Therefore, the total load is just the sum of the 2. So my W1 is 150 pounds per square foot. So each one of these holes right here, that one, that one, that one, that one, that one, that one, and that one, depending on which equations I select, that's going to be all 150. Okay? So we turn it over. We go to the next page. The next page says, gather your data. I needed 2 sets. I need the stresses and the properties. The stress table is going to give me F. It's going to give me E. And it's going to give me H. So I'm going to do that first. I'm going to go for stresses first. F, H, and E. Okay, I go to the table, 4-2. I put my finger on Doug fir. There's Doug fir larch. I put my, that's the species. I go grade, construction grade. Last one's construction. I go across and I see little f is 1,050. I've already got x's through the next two columns, so I move over and it looks like h is 140. And I continue on and I go to the last column and it's 1,000,005. Okay, if it was plywood, I would be done with moisture. It's boards, so I have to worry about moisture. So they're going to get wet, so I go to the moisture adjustment. It says I got to reduce this to 86% of the value. I've got to reduce this to 97% of the value as I do that. So that takes care of the moisture. Why did I do it with moisture? Because it's boards against the concrete. Now I got duration. Use only once. That's the increased load duration. It says if I use it for very short, I can increase it by 1.25. Move across, H is increased by 1.25. And move across, and E is increased by nothing. So, if you look at your handout, look at it. It's right there on page 615, about 8 or 10 lines down. That's where they got those three numbers. For H, 3 numbers for F, and 2 numbers for E. And when they did the math, I'm going to use their numbers. They got 1129, they got 170, and they got 1,455. So that's how they got those. There's one thing, and this is another thing. This was moisture, this was duration. Okay, I got those. Now I need the properties of them. I need to get, I've already got W, okay, right here, W1. So W is taken care of. I've got the F, H, and E taken care of. It looks like I need the I, the S, the B, and the H. Okay, why don't I need rolling? So what am I going to be using for this? I'm going to be using, for our slab example, I'm going to be using that one. I'm going to be using 1 by. So I'm going to be using this equation. And then I got to figure out what the constraints are for the sheathing as far as deflection. So they didn't really tell us a whole lot, I don't think, but they did down the road. They told us for the sheathing, we're going to need to check L over 360 and 1/16. So these are the two I'm going to be using for slab. So my first iteration is going to be using this for bending, these two for deflection, and that one for shear. So in order to do that, it looks like I need the first one, I need an S. So I got to have an S. Second one, I need an I. Third one, I need a B and an H. A B and an H. So if I have those letters, I'm ready to go. I can figure out this, what spacing to put the joists. So here our first iteration is going to be how far this is going to be. And I'll call that L1. Spacing of the joists. So S. Okay, now this is a little confusing. Unfortunately, a 1 by 12 isn't what I need. I need to design a 1 foot strip. Remember when we did slabs? We did a 1 foot strip. I'm going to take a 1 foot strip of this 1 by 12 inches wide, and I'm going to look at it. So my cross section is this: 12 inches wide, and a 1 by, if you look it up on the table, is 3/4 of an inch. So that takes care of 2 of them. My B equals 12 inches. My H equals 3/4 of an inch. That's B, and that's H. Now, how do I find the rest of the letters? That takes care of these 2. Okay, they're gone. Okay, these 2. Unfortunately for boards, you have to go to page 666 in your text. And if you go to 666, you're going to get equations for each. I, B, D cubed over 12, S, B, D squared over 6. So if I put the data into there, this should be 3/4. 3/4 there. 12 B, excuse me, B 12 3/4 cubed over 12, and this is 12 3/4 squared over 6. And that should be what your handout did. If you look at the handout there, 12 3/4 cubed over 12 gives me I, that's 0.42 inches to the 4th. And the strip, 12 3/4 squared over 6 is 1.13 inches cubed. Okay, I've got all my data. Now all I got to do is run through it. And this is a quick process now, okay? We're going to do spacing of joists first, spacing of stringers second, spacing of shores third. So we got to run through this 3 times. So let's write down our equations. Slab joist, joist spacing, bending, L equals 1.69 square root FSW. Okay, we got them. The data's right here. Don't have to go too far to get it. It's right next to me. W was 150. F, 1129. S, 1.13. There's equation number 1. Whipped. Deflection. L over 360, 1/16. L, 1.6. Ooh, I screwed this up. Excuse me. 10.95. Cube root. E, 1,455,000 EIW. Okay, let's fill it in. E, I, W. Takes care of that one. The next one, hopefully you can see the radical is the same. That's a ditto. That radical and this radical are the same. That's deflection. Shear. dimensional, big L. Okay, that's the equation. Okay, and if I look at that thing, H comes from right here, 170. B is 12. D is 3/4. And W is 150. All I got to do is multiply. And when I multiply those out, they should come out hopefully the same as they have. I got the 31.9 inches. Next one, 27 inches. That was L over 360. 1/16 is 25.8 inches. And the next one came out to 11.3 feet. And you multiply that by 12, you get 136 inches. So what do these things tell me? First of all, it tells me that if I wanted to worry about bending, the farthest I can use L1 is about 32 inches. If I was worried about deflection, it looks like it's about 26 inches, and shear is not a problem. I can space them all the way out to 11 feet. So which one do we pick? Since all of them have to be met, that's the farthest apart I can have L1. Okay, they did a little bit of surgery here on a test. You're not going to have to do that. I'm going to make those numbers so they work. If you look at the top of page 615, it says, okay, 25.8 is the best. It says probably, given the 7 joists and stuff, put 7 of them at 26 inches and 1 at 24. That makes the 15-foot bay work. So for us, we're going to use 26 inches. So for this particular problem, my joist would be spaced at 26 inches. That takes care of that guy. Okay? So that's one. Okay, now I'm going to get rid of this data right here. And I can get rid of this one altogether. And I may be getting rid of this one. I don't know.